Okay, so how close can you get to the finish line? How many of y'all played Mario Kart before? Okay, cool. I would school all of you. Anyways, so what you would do in this scenario is your goal is to get your team's car to the finish line without going over. So you would like, those like pullback toys and then they like roll. Okay, so that's what you would do. The catch is the distance will not be revealed until later. So you like practice, you figure it out, and then eventually I would tell you the distance and then we would test that theory, right? Okay, so let's say that you pulled back, 2 inches. Okay, the distance traveled, let's say it's about 4 inches. Okay, let's say you simulated this multiple times. So you got 4 inches. Then you did it again and you got 7 inches. Then you did it again, you got 5 inches. Then you did it again for 4 inches and it was 12. Let's say you got 8, 10, 20, bless, 22, 17, 35, 35, and 38. So again, hypothetically speaking, you run this scenario for all these different inches. Okay. So that's where we're getting all these numbers. You would have simulated this. Okay. Now we are going to sketch a scatter plot. We're going to find the equation for the line of best fits. Okay. So we're going to go into our applets. And I'm going to show you how to do this a little bit later on your graphing calculator. Nope, JK. Nothing wants to work today, dude. It is a sign. 45, 35, 38. Okay, after which number? 22, 17, 45, 35, 38. 17, 45, 35, 38. Okay, so it should be this first one. Yeah. Thank you. Let's see. Okay. Split. So we did 2, 2, 2, 4, 4, 4, 6, 6, 6, 8, 8, 8. Okay. I'm hoping that this is the right one. There we go. All right, so here is your scatter plot. Yay, so pretty. Okay, can you copy that down? Okay, first of all, okay, go ahead and copy that down on model A. You can approximate. We just need to get like the picture. Yeah, Victoria. We should watch a stats movie. Gotta find one first. I would walk out. We're gonna watch a movie. AP Stat, the movie. No. There is a class in college that is called the history of math. That's one of my favorite math class because you like learn how to calculate like Egyptian math and like Greek math. Yeah. Yes. It was cool. I was a fan. I was nerding out because it wasn't like super serious. It was kind of just like the enjoyment of learning instead of like, hey, you've got to know how to do all of these things. I think we wrote like 4 papers and called it a day.
Really?
Yeah, it was awesome.
Nice.
Yeah. Why is my chair so? There we go. All right, everybody good? Okay, so now we're going to calculate the correlation, which the R is 0.939. Because they calculated it for us. Okay, we're going to calculate the least square regression line. So on your scatter plot, you're drawing this line. Okay. And good. Yep, R is 0.939. What would that make R squared? So what is R squared? What is 0.3939 squared? You've got a calculator. God bless. That would be 0.82. Okay. You're welcome, class. Okay. Then you're going to draw the residual plot. Okay, here's your residual. Remind me what residual means. Mm-hmm. And then here's our equation right here. I'm going to write it out for you. So y hat is equal to negative 9.33 plus 5.58x. It has always bothered me that they put the a plus bx instead of ax plus b. Yeah. Because that's actually how you learned it in like algebra, right? Yeah. Yeah. Always bugged me. I just work here though. I don't think anybody would take off points for that. I feel like if they take points off for that, they might as well just like give you a 1 at that point. Like if you got the equation right, but then it was just like flopped. So you would. It does calculate it for you. I'm going to show you how to do it in the calculator. You don't want to do it by hand. You would have to draw the straight line and then see where it crosses the y-axis, and then you would have to calculate the slope. Like, and that would be a hand calculation. It would be a very long time. I would prefer you doing it in a calculator. Yeah. Yeah. Okay. So you're writing that equation, you're drawing the residual, you're drawing the scatter plot. So now what should we do on part B and part C? Do you see these functions on part B? So it says like model 2. It says plot x squared comma y. So that means that we're going to take all of our x values, so all of our pullback distances, and we're going to square all of them. Okay? So you'll go back into your table, and then you'll put all this stuff in. So go ahead and take a moment. I want you to draw the scatter plot, write the equation, find R squared, and write the residual. So you're going to need your laptop probably, or a friend's laptop. Boom. All right, so when you go in here, you're changing all these numbers to be 4, 4, 4, then 16, 16, 16, then 36, 36, 36, and then 64, 64, 64. And begin analysis. Begin analysis. All right, so here's our scatter plot. Okay, and we're going to calculate the correlation. And we're going to hit calculate least square. Bruno! Good morning. Okay, there's all your information. Are there any questions about how you got that? Or like putting it into the applet? It looks like this. Dang, got him. It's the exact same thing. It's just moved over. Because like, look at your numbers. The only thing we changed was x squared. Right? Okay. And then there's your residual. So go ahead and copy those down if you don't already have them down. Okay. You also can put this in your calculator. Okay. So we're going to do that on the last one though. Didn't expect them to mess up. Sorry. There's your equation, your r squared. Using your applet on your computer, I want you to try doing it in your calculator. So remember how you create your scatter plot is you go to document, you go to new file, you hit add list and spreadsheets, you're going to enter your data. On this one, on model 3, you're putting in the X values like normal, but for your Y values, you're going to do log of whatever the value is. Okay? Make sure that you locate where log is on your calculator because you're going to need it. Okay? All right, so go ahead and do that now. Okay? So putting in that data. When you graph this, okay, you should have gotten something like this where you get 3 in a row. But, so you're gonna hit menu, then you're gonna hit analyze. Give me 1 second then. 1 second. Because there's a CX2 and then there's the CX. So all right. So yeah, probably stats. So then you're gonna draw that straight line. What type of function is this guy? If I have x comma log of y, what kind of function is that guy? Your options are linear, quadratic, or exponential. There you go. Okay, so this is an exponential. Okay, for your equation, you should have gotten y hat equals 0.416 plus 0.146x. Wow. And then your r is going to be 0.978. And then your r squared is going to be 0.956. Your residual is a little bit closer to the line. Okay, so it's a little bit closer to the line, but not quite. So which model is the best choice for your data? That's probably going to be model 3. And because it has the highest r squared value. Why does that matter?
How much of the y value, like this one variable, can you explain that?
Okay. It's the closest to 1. I mean, but like, why does r squared matter? Closer to 1 means that it has the best fit. Okay. 1 means that it has a perfect trend, like you were saying, cause and effect, right? Okay. So the higher that r squared value is, the closer to 1 it's going to be, the more close to a trend and basically being able to say that this causes this to happen, right? Okay. The residual plot shows no pattern. The residual shows no pattern. We like chaos with the residual because then that means we've got a stronger R value, stronger R squared value. All right, calculate how many inches you will have to pull back to finish the line of 80 inches. So let's say that we have log of 80, and that's going to be equal to 0.416 plus 0.146x. We're going to subtract that 0.416, and then we're going to divide by 0.146. And that's going to give us x equals 10.2 inches. Okay. Go into your calculator, make sure that you can do this. So you should have gotten your scatter plot. Okay. Once you got your scatter plot, you're going to hit menu whenever mine loads. Should be, because then it has like y equals a plus bx. Okay. Okay, so you're gonna hit stats, and then you're gonna hit stats, and then you're gonna hit stat calculations. Oh, menu, stat calculation. And then you're gonna do linear regression. So number 4. Okay. And then you'll put in the information. Okay. Good. All right. Go ahead and flip. Okay. So what we went over was choosing the line or choosing the best regression line. Okay, so 1, we got to check the scatter plot. And see if it has a linear pattern. 2, we're going to check the residual. For no leftover pattern. And 3, we're going to check R squared is close to 1. That's giving us the best fit, okay, the best model. So you don't just go based off of sight, you go based off of, does it have a linear pattern? Does the residual have like chaos? And is R squared closer to 1? It's either. Oh, yeah. He said Merry Christmas. So all you're doing on these 3 is taking 80,000 and literally plugging it into each equation. With huh? Yeah. What model speed? What? Is it 80 calculus or just 80? It's just 80. Because I think it says like in thousands, right? Okay. So you're going to plug in 80 into each equation. So this guy We plug in 80 into the equation. Okay, and that gets you 82.2 years. The next one, when you plug that one in, you get something like 82.4 years.
Yeah.
And then the next one, you plug in, you get 81.7. Are there any questions? They gave you the equation, which makes it easier. Which model would make the best predictions for life expectancy? Why? Right? Okay. The scatter plot is going to be most linear, and so the residual has no leftover pattern. Yeah? We want chaos in the residual. Yeah.
Okay, but like, I don't listen to rock music back in the some like the losers just don't
Questions on this one?
Yeah, exactly. They're gonna hit me with that.
Like the short answer things, your numbers are going to be different than what I would have. Okay, so what is the explanatory response on here?
Number of
Explanatory is the number of rubber bands. Number of bands. Okay, what is the response? Distance traveled without RV feeding per basin, right? Okay, cool. Then you drew your little scatter plot. Mine looks like that, roughly. Nope, okay, it was a little bit more straight line-ish. Okay, cool. This should be two categorical applet because we have the number of, two quantitative, because the number of bands and then the distance traveled. So those are two numbers. Does that make sense? Okay. And then describe the relationship. So this is what we write. There is a strong positive linear relationship. What's our acronym for this guy? Stuffs. And plus context. I always have you ever seen The Simpsons? This is the alcohol that they drink in Simpsons. You remember? Okay, cool. Well, I mean, it's just some way to remember it. Okay. So relationship between, and we've got to put it in context, number of rubber bands and distance traveled. Are there any like outliers or anything crazy going on? No. With no unusual features. Now, again, yours might be a little different, but still should have the same relationship description. Still should be positive. The more rubber bands, the more distance traveled, right? Otherwise, you messed up. What? Okay, so we're going to estimate the correlation of your distribution. What would you say the estimation is? R equals, is it closer to 1? Is it not closer to 1? Closer to 1. So we're going to say it's about 0.98. Now, if you want to say 0.9, whatever, that's fine. Are there any units for R? No. Okay. So R is going to equal about 0.98 and no units. All right. We're going to calculate the correlation R using the applet. If you would have put in your data, it calculates it for you, right? So mine was about 0.995. we've got to interpret. So linear relationship between number of bands and distance is very strong and positive. Okay, so then you're going to find the least squares regression line. It does it for you. Okay, so this is why knowing your calculator is an important thing. Okay, you should get something similar, maybe not exact, but distance is going to equal 25.25 plus 10.01 times the number of bands. Okay, this is your important part. So if you haven't gotten your equation for your data, you need to do that now because otherwise you can't do what we're about to do in just a second. Okay. Okay, so interpret the slope of the least square regression line. So that means that for every one band, we predict the distance traveled increased by 0.07 centimeters. So for every one band, we predict the distance traveled increased by 10.07. If we want to interpret the y-intercept of the least square regression line, it means that with 0 rubber bands, the predicted distance traveled is 25.25 centimeters. Again, your data is going to be different on these next couple of ones. Yes.
Why did I get that reference so quickly?
All right, so now we're going to calculate and interpret for 4 rubber bands. Okay, so we're going to plug in 4 into our equation. So we got 25.25 plus 10.07 times 4, and that gives us 65.53. If I want the residual, then I'm going to take 63, which is the what we actually calculated, minus 65.653. And that gives me a residual of negative 2.53. Your data is going to be different than my data. Okay, so the actual distance was 2.53 less than predicted. That was what I calculated. So remember, this is from the equation. 63 is what we measured. When we put 4 rubber bands on the doll, yours is going to be different. Your number is going to be different. Okay? You're going to sketch the residual, and you're going to find your R squared, and interpret it. Okay. So all of these things are going to be different for your data. Okay. So we're going to put a pause on this. I want you to go ahead and go down. The number 20, and we're going to use our model to predict the number of rubber bands Barbie will need to have the most exciting yet safe bungee jump from a height of, let's do 30 feet. Let's do 30 feet. Okay. It's not? No, it's not. No way. It's about, I didn't measure it. I didn't go out there yet. Let's go measure it really quick and we'll fill that out. So here's what you need. You need the bag of rubber bands, or a handful of rubber bands is what I gave you. Okay. You need your Barbie, you need a pencil, and you need this paper. Maybe a calculator too. Okay. All right. So grab your stuff. Okay. So this is what happened.
Oh, I went down the
There it is again. I got you. Their dollar is bigger. Tater tot is a huge budget. That is true. Okay, so what you are working on is you are finishing up 10 through 20 on your own. Okay, 10 through 20 on your own. Okay.